In this video, we are going to look at one example problem based on LR circuit in AC. So AC response to LR circuit. So let us read the question first. A resistor with resistance 300 ohm and an inductor are connected in series across an AC source that has voltage amplitude 500 volt. The rate at which electrical energy is dissipated in the resistor is 216 watt. So let us draw a circuit for this first. So AC source, and we have two components, L and R. R is given, which is 300 ohms. We are also given that AC source has voltage of 500 volt. So this V is 500 volt. The rate at which electrical energy is dissipated in the resistor is given as 216 watt. So this electrical energy which is dissipated is represented in the form of average power dissipated across the resistor. So we can write from here that what is given to us. What is given to us is R is 300 ohm. Voltage of the source is 500 volt, and power dissipated, which is the average power, which only dissipates across the resistor. So even if you have a capacitor in the circuit or inductor, we know that L stores energy in the form of magnetic energy, and if there is a capacitor in the circuit, it will store energy in the form of electrical energy. But the loss of power or the energy transfer which happens in the circuit is only because of presence of resistor. If you have like superconducting wires which have zero resistance, then there will be no power dissipated across the resistor. So here the net transfer of energy only happens across R, and which is given by P average, which is given to us as 216 watt. Now let's see what is asked. So we have to calculate impedance of the circuit, that is Z. We also need to calculate the amplitude of voltage across inductor. So we are asked VL, and then we are asked to calculate the power factor, which is given by cos of phi. So we have to calculate this cos of phi also. We will see what is phi again here. So in order to solve this question, first we need to look at the relationship between the power dissipated, which is given as 216 watt, and the impedance. So the first question asked is what is the impedance in the circuit. So the power is given by, so let us also write what are the equations that we are going to use over here. So P average is given by 1 by 2 I square R. So from where this 1 by 2 term is coming now, you might think. So power is I square R. We know that, right? So P is I square R. This I is the instantaneous value of current, where this instantaneous of value of I is actually dependent upon sine. So there is a sine term over here. So if we take a sine wave, which is like this, and here we will have the magnitude. So if this is what I have plotted is sine of theta versus theta over here, then you will see that the values will fluctuate between +1 and -1. So if we take the average of this I, which is dependent on sine of theta, will be 0. But now we need to take the average of sine square of theta. So if we look at, I'll just take it a bit to the left. So if we take the average of sine square of theta, then here I am plotting sine square theta versus theta. Then what we will be having is, we will have no negative values because now everything is squared, and square, the highest value still remains plus 1 because previously our high was plus 1, which has now become plus 1, and the minus was minus 1, which is also squared as plus 1. So here, if previously I had these values, then if this was 0 to pi and here we reached 2 pi, now this pi would be here, and this negative is again, and this negative is coming back over here, and it is twice of pi. Now that's why when we take average of sine of theta, it comes out to be 0. But now when we take the average of sine square, that average will lie in between, and hence it will give us the value of 1 by 2. So coming back to this, we have, when we calculate the average power dissipated, it is given by 1 by 2 I square R. Hope that is clear now. Let me erase all of this. Okay. So now we have written what is the P average, but what we are given in the question is R and V. So we need to figure out what is the relationship between Z and I. So we are given P average already. We know the value of R. From the given quantities, we need to figure out what is the value of I in the circuit. So we can calculate I from this equation because P is given to us. So what we are trying to do is, we are trying to calculate the impedance of the circuit, which is the impedance in the circuit is the total resistance offered by circuit in AC, which is given by voltage applied across the circuit divided by the total current. So now we need to figure out this value of I. V we already have. Then we will get to know the value of impedance. This I we can calculate from this power calculation. Hence, I can write this I as root of 2P average divided by R. So if we substitute this, we can write it as V divided by root of 2P average divided by R. Now let us substitute these values. So that will give you the solution for A, which is calculation for impedance of the circuit. So Z equals V, we are already given 500 volt divided by, we will take the root of 2 multiplied to P average is 216 divided by resistance, which is 300. And if you calculate, this will come out to be 417 ohms. Now let us go to the second part. What is the amplitude of voltage across the inductor? We are given voltage across the circuit, that is voltage of the source, and we are asked to calculate what is VL. Now if you recollect our phasor diagram for L, C and R, then, so now if we look at the phasor diagram for LR circuit, then we know that whatever is the direction of the current, R and voltage across resistor and current are always in phase. So they rotate together. So from that we can take, if this is my I, then same will be the direction of VR. But in case of, but if we have inductor in the circuit, then we know that the voltage phasor leads the current phasor by 90 degree. Hence, our VL will be in this direction, which will lead the current phasor by 90 degrees. And now hence the resultant of these two we need to figure out, which can be given by, let's say my resultant is this blue one which I am drawing, which is, let's say, this. So this voltage is given by I multiplied to Z, and if we look at the geometry, then I can take these two vectors. So this will also become VL, and we can write as V square equals VR square plus VL square, and here we need to calculate VL. So VL square is V square minus VR square. If you know all these derivations, then you can just skip directly to the final step, but I am just revising it for the sake of continuity. And we know that resistance and current are always in phase. So VR is given by I multiplied to R. And we have both these quantities. So we can calculate VR as I into R. Current, actually we should have calculated separately. Let us do it now again. So this I will be this root of 2p average divided by R multiplied to R. So let us substitute. In fact, this can be revised as root of 2p average multiplied to R, because this will become square and it will cancel out 1. So if I take it inside the square, this will go away and 1 will be left. So let us substitute 2 multiplied to 216 multiplied to 300 and root. Let me calculate it on calculator. So this comes out to be 360 volt. So hence we got VR. Now we know V and VR. Substituting this, we can get to know the value of VL. So this is our question B. VL is V square, so that V was 500 square minus 360 square, which will come out to be 347. So this is our answer for part B. Now let's go to part C. Let us go back to the question. In part C, we have to calculate the power factor, which is given by cos of phi. Oh, we did not draw phi in the diagram. So this is the phi angle which your resultant voltage vector is making. So now we need to calculate power factor. Let me do here only, because we will need only this diagram for that. So C part is calculating the power factor, which is given by cos of phi. So from this diagram, we can see that cos will be base upon hypotenuse. So base is VR and H is V. So it can be given by cos of phi will be VR by V. And both values are known to us. So VR is, how much we got? 360. and V is 500, and it will come out to be 0.72. So this is our answer C, which was cos of pi and which we got as 0.72. If you have any doubts, please post it in the comments. Thank you.